Hello, good morning students, and welcome back once again to another video for the electricity chapter and the exercise. Today I have once again two numericals for you which are quite simple, much simpler than the ones that we did before. Okay, so let's start without any further delays. So the first question states that two lamps, one rated 100 watts and the other is 60 watt, both using 220 volts, are connected in parallel to electrical mains supply. What current is drawn from the line if supply is 220 volts? So this is electrical main supply. That means these are the two bulbs that are connected in parallel at a certain house or a shop, whatever you can imagine to be, because this is the main supply, not a regular circuit, the ones used in our domestic purposes. And we know that in domestic use of electric current, the supplies are always connected in parallel, so that if one of the line gets broken, the other one still works and the potential difference remains the same for all. And that is why both the bulbs has the potential difference or the electric potential required to be 220 volts, and the potential difference given is also 220 volts, so no need to worry about that. Now the question is, what current will the line draw? Okay, so because they are in parallel, potential difference is same but the current will be different. So you can either find the resistance for both, find the total resistance, and then you can find the current as well. But why we don't need to find the current? Because if you remember the formula for power, P is equal to VI. You can get the current directly from the formula of power, and we have been given the formula the value of power, that is 100 watts. So I can write that power P1 is equal to, potential difference is going to remain the same, so I am writing V as it is, and current I1. Similarly, power P2 is equal to VI2 for the second one. So the bulb 1 is having the power of 100 watts, so I am writing 100 is equal to 220 into I1. Similarly, I am writing 60 is equal to 220 into I2. Okay students, I hope it is clear to you. Over here I have just kept the values of the power of the first bulb, that is 100 watts, and because the potential difference is same for both of them and they are in parallel, so I can directly write the values and find the current. So once I find the values, and then the current I1 and I2, because they are both in parallel, when I simply do the addition of this, I will get the total current flowing in the circuit. Okay, so finding this, what I get is ultimately finding the value of I1. So 220 goes on the other side of the equal to sign, so in the denominator of 100, and it becomes like this, I1. Similarly, 60 upon 220 is equal to I2. Simple cross multiplication on the equal to sign. Solving this, you will get that I1 is equal to 0.45 amperes and I2 is equal to 0.27 amperes. Okay, I hope it is clear to you students. If you have any doubts regarding this question, you can ask me in the comment section. Okay, what I did is simply took the value of power P1 and P2, just kept the values, and then simple cross multiplication, because we need to find the value of I1. So cross multiplication, 220, when it goes on the other side of the equal to sign, it becomes in the denominator. Similarly, when this 220 goes on the other side, it comes below the 60 value of the power. Now that we have the value of current I1 and I2, because this is the current I1 flowing over here, that is 0.45, and this is 0.27. When both of this current meet at this point, okay, what will happen is, in this main line, they both will add up because they are going in separate ways, but when they come together in one single line, they add together. It's simple like a water flowing in a pipeline. When two pipelines combine together in one single junction, then the water coming will get add up. Similarly, I can write the total current I is equal to I1 plus I2, that is 0.45 plus 0.27, and when you solve this, you will get the answer to be 0.72 amperes. Quite simple. 7 plus 5 is 12. Carry on. 4 plus 2 6 and 1 7. So the answer is total current I flowing in the circuit is 0.72 amperes, because the question is what is the current drawn from the line. So you are not supposed to find just the individual current, you are supposed to find the total current that is being drawn from the 220 volt main supply. Okay, I hope it is clear to you, students. Moving on, the next one is even simpler. Which uses more energy, a 250 watt TV in 1 hour or 1200 watt toaster in 10 minutes? So we have to find which one is using more energy. So the first one is TV. So TV is having power of 250 watt and it is being run for time t1 is equal to, I can write p1 for TV, and time t1 is 1 hour. Okay, similarly power p2 is 1200 watts, 1200 watts, and time t2 is 10 minutes. So just 10 minutes. This is TV and this is toaster. Okay, now we need to find the energy. So if you remember, the formula of power is P is equal to VI. But if you remember, we did something about electrical energy or heat energy. If you remember, when the power is used for a certain amount of time, energy is dissipated. Similarly, energy consumed also has the same formula. That is, energy consumed is equal to power when it is used for a certain amount of time. This will give you the formula. This will give you the answer in joules. Okay. If you remember, last year we did something regarding this power when we studied about work and energy chapter in 9th standard. If you remember, power is equal to work done upon time taken, and we know that work done is energy consumed. So I can write energy consumed upon time taken, and cross multiplication power into time will give me energy consumed or work done. The same thing is being applied over here. So energy consumed is equal to power into time. Same thing, just in the terms of electrical energy. And time is always in seconds. When you want the answer in joules, the time is always in seconds. So first things first, you will need to convert this 1 hour into seconds. So 1 hour has 60 minutes. So 60 minutes, and 1 minute has 60 seconds. So it becomes 60 into 60. And similarly, 10 minutes into 60 seconds. Now we simply apply the formula. So energy E is equal to power, that is 250 watts, into 1 hour, that is 60 into 60. When you solve this, you will get the answer as 25 into 6 into 6 is 36, 10, and this 2 zeros as well. Okay, so 25 into 36 is 900. Okay, and this 1 0 and the 2 zeros over here, we have total 3 zeros, so we simply add 3 zeros in the back. So this many joules of energy is consumed, or I can write, removing these 3 zeros, I can write 900 kilojoules. So I have converted joules into kilojoules, dividing it by 1000. Similarly, this is energy E1 for the TV. Now energy E2 for the toaster. Now toaster is having the power of 1200. Okay, so 1200 into, now I have time that is taken as 10 minutes into 60 seconds. Okay, now 12 6 we know it is 72, and 1 2 3 and 4 zeros, 1 2 3 and 4 zeros. Similarly, I convert this into kilojoules by dividing it by 1000. So removing the last 3 zeros, dividing by 1000, I get 720 kilojoules. So the final answer is, which one is using more energy? So the answer is TV. So TV is using more energy. So TV is using more energy. It is quite simple, students. Okay, the power of TV is much less compared to the toaster. That is why the comparison was required, that which one is using more energy. And once we solve them, we get that if the toaster, even it is used for just 10 minutes, it consumes 720 kilojoules. Okay, and the TV, which is consuming only 250 watts, when it is run for 1 hour, then it will consume 900 kilojoules. Quite simple actually, just getting the formula of energy, that is or energy consumed, that is power into time, that we got from the previous year's formula. That is, power is equal to work done upon time taken, and work done is equal to energy consumed. So we can write work done as energy consumed over here, That is why the work and energy has the same unit as well, joules and joules. If you remember, we talked about this topic in the last year when we studied work, energy and power. Quite simple. Similarly, we find the formula for energy over here, cross multiplication of time. So we get power into time as energy. Now simply applying the values, the only thing that we need to worry about is converting hours into seconds and minutes into seconds. Don't forget that, otherwise your answer will be wrong. Always convert that into seconds. That's all for today, students, and we'll talk more about this chapter in the next video. Till then, have a nice day.